question 15b, we have a wooden block of mass 2 kg is slide down with constant velocity on an inclined rough planes of 30 degrees from the horizontal axis. Okay, so you have a block and it slide down at constant velocity on a rough plane that inclined at 30 degrees. Okay, so class, see the keywords constant velocity. So constant velocity means the acceleration is 0. So we understood we have to apply Newton's first law. Okay, you have to apply Newton's first law, whereby the summation force equal to 0. Okay, so question 1. Sketch a free body diagram to show the forces acting on the wooden block. So we need to sketch our FBD. So let's say this is our inclined plane. Put our inclined plane. Then represent the block with a dot. So what force we need to draw? So the block have mass. So we have weight straight downwards. Weight for the block. And then the block is put on the rough inclined surface. Contact with the surface. We have normal force perpendicular to the surface, and then it slide down. The block is moving downwards. So when the block is moving downwards, because it's a rough surface, also it means that parallel to the inclined plane, we have friction force acting upward. But then class, this time, since the block is moving, so the friction force will be kinetic friction. Okay, kinetic friction. Then there is no tension here because we didn't attach the wooden block with any string. So no tension. We didn't apply any external force. So kita tak perlu lukis external force. So the only force acting is normal, kinetic friction and weight. Okay, so this is our free body diagram. Then second questions. Calculate the kinetic frictional force between the wooden block and the rough inclined plane. So class, we need to find Fk. We need to find Fk. So still remember, in order to find for the forces, we need to apply Newton's first law, because the question said is move with constant velocity. So to solve the questions, we have to follow the step lah. So after we draw our FBD, we have to resolve the forces before we can apply the Newton's law. But then class, sebab FBD ni adalah jawapan kita untuk soalan 1, so tak sesuai lah kita terus buat resolving atas ni ya. So kita redraw balik gambar tu untuk resolving. So normal Fk, then we have weight. Okay, so we put our axis. So this is my x-axis. This is my y-axis. So the angle should be here lah, 30 degree. Okay, so then kita buat resolving. So the force that we need to resolve will be the weight lah. We can resolve into component y will be weight cos 30, and then the component x will be weight sin 30. Okay, so we have done with our resolving. Then we can start to apply our Newton's law in order to solve the question lah. So we want to find Fk. So mana Fk? Tengok Fk duduk pasti X. Okay, so highlight kan all the forces yang ada dekat komponen X ni. So after you do like this, you can see very obviously along the x-axis you have two forces. So the summation force along x-axis is equal to 0. Why I equal to 0? Why I apply Newton's first law? Because the question said is move with constant velocity, no accelerations. So we have Fk minus W sin 30 equal to 0. So it means that Fk is W sin 30. So W is mg, so sin 30. So the mass The mass of the block is given 2 kg. So 2 times 9.81 psi 30. Then you can pause the video to do the calculations. So you will get the kinetic frictional force acting is 9.81 Newton. Then we solve question 15b.